Give me a second. It work. My mic is working now. My mic. Okay, 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 okay. So, so I'll repeat what I said. I think, yep, it's back finally. So, okay, welcome to the sixth stream of Learn Rust with me, where you'll be learning Rust with me. I mean, literally with me. And well, because the with me part is basically because I am learning Rust for the first time. So basically, it's a learning process. You will be learning with me. That so this basically because well, I do have experience in other languages, but I am lagging behind in certain skills that I need for the modern job market. So I'll be upskilling myself. You always have to upskill yourself. You always need to learn. You have to always keep learning, because if you don't keep learning, then well, you will fall into a brain rot. You're basically, so you need to keep learning new things. Well, it's a good thing to keep upskilling yourself. And we'll actually start where we left off. Actually, yesterday I had to go for some business, so I had to end the stream short. We'll be completing loops here. And so last stream we actually did till we actually did this example up here, which is this loop labels to disambiguate between multiple loops. So I already told you how this works. I actually need, you know, if I had a, Wacom or something, I'll actually give an explanation, you know. So I need to buy myself a drawing tablet. Hmm. I'll see about that. I'll think about that later on. We need to continue with, where we left off. And over here, conditional loops with while. Okay, so till now, we have learned that we there are three types of loops: loop, for and while, and till in last till last stream we have covered loop. uh, I'm saying till because loop is actually used in the example, a guessing game example, and I've actually used it for my own coding, which was I was making something myself. So if you could just give me a second here, and I need to check something. Okay. Okay, so we are good on that. We'll continue here. A program will often need to evaluate a condition within a loop. With While the condition is true, the loop runs. When the condition ceases to be true, the program calls break, stopping the loop. Okay, so basically, it's a while loop. It's so this is a new kind of loop, other than loop. Uh, we'll also, cover for. So this is a while loop. Okay. So basically, if I want to explain a while loop, I will explain it, but we'll actually read this text first. Is it's possible to implement behavior like this using a combination of loop, if, else, and break? You could try that now in a program if you'd like. However, this pattern is so common that Rust has a built-in language construct for it called a while loop. Okay. In listing 3.3, we use while to loop the program three times, counting down each time, and then after the loop, print a message and exit. Okay. So if we were to change this loop, okay, sorry, so we could actually do something like this. So, okay, let me explain what I'm about to do. If I use the while loop, okay, so what I can do here is I can remove this if condition over here. So if I want to, you know, do basically I want to emulate the same condition, but in the loop. So I what I would do is remove this, and then instead of loop we'll write while while remaining no is greater than 9. There you go. So this would actually work the same way as where did it go? This would work the same way as this code before here. Because see, the thing is, the condition was if remaining is equal to 9, then it would break. Okay. So basically, what I did here is the same thing. So remaining is 10, okay, and it gets into the loop. Then it would print the remaining. Then it would say -1. Okay, no, it won't do the same thing actually. We'll do greater than 8. So now, sorry, now it will do the same thing. Because see, what would have happened in while remaining greater than 9, it wouldn't have printed this remaining. So now this will do the same thing as the other program. See? Yep. So remaining is greater than equal to 8. So basically what would happen here is remaining is 10. First it will show remaining equal to 10. Then it would, -1. Yep. It would subtract by 1. Then it would go back to the starting of the loop. Then it would, you know, print the remaining 9. Then it would subtract by 1. So the value of remaining now becomes 8. So this time remaining is not greater than 8, it is equal to 8. So since this condition is false, it would exit out of the loop just like this. Remaining equal to, so it basically did the same thing. Okay, so this is how we do while. Okay, so this construct eliminates a lot of nesting that would be necessary if you use loop, if, else, and break, and it's clearer. Exactly. So I just reduced an in if condition which was here, which was if remaining is equal to 9, then break. So I saved a few lines by changing the loop to a while, basically. Uh, okay, now that okay, While a condition evaluates to true, the code runs, otherwise it exits the loop. Okay, that's fine. Looping through a collection with for. You can also use the while construct to loop over the elements of a collection, such as an array. For example, the loop in listing 3, 4 prints each element in the array A. Okay, fn main, and then we have this while. So here the code counts through the elements in the array. It starts at index 0. Okay. Obviously index 0, which means it would display this first. Okay. Then loops until it reaches the final index of the array. That is when index is less than 5 is no longer true. Exactly. So what would happen here? Okay. It would start from 0. Index is 0 is less than 5. Value of you know z- value of the array at that index, at the 0 index, is 10, so it would print 10. Then index would be increase, it would be increased by 1. Sorry, 1 is less than 5. Then it would print the second element, which is a1. So since arrays have you know so they are zero based indexed, they have zero based index. The index starts from 0, so the first element is at a0. That is the basic thing. So index plus 1. So then after it prints this at a1, okay, which we were, then it would increment the index. Then 2 is less than 5. So basically, because the condition is 2, index is now 2, 2 is less than 5. Then the third element, 10, 20, 30. Then it increments by 1. The index is now 3. 3 is less than 5. Okay. It would print 40, because A3 is 40. And then it would increment 1 more time. The index would now become 4. 4 is less than 5. That means the last element of the array would be printed. Since if you have a array with 5 elements, then the last index is actually the number of elements minus 1, the last index of that array. So basically, now you have the final index a4. After that, it will increment by 1. It would add 1. And now, since 5 is not less than 5, actually, 5 is equal to 5. So this condition would be false, and hence the loop would stop. So that's, I gave a longer explanation, but well, since I know this, so I, like, if it would be only me learning, then I would have just speed ran through this section by myself. But since I'm streaming it, then I have to give an explanation, for in case there are people who still have doubts, so on how this works. All 5 array values appear in the terminal as expected. Even though index will reach a value of 5 at some point, the loop stops executing before trying to fetch a sixth value from the array. Okay. However, this approach is error prone. Um, and we would cause the program to panic if the index value or test condition is incorrect. Yes, exactly. For example, if you change the definition of the A array to have 4 elements but forgot to update the condition to while index is less than 4. Exactly. So basically it's saying If I, let's say I removed 50, okay. So let's say I removed 50. Then let MUT index equal to 0. And I just kept this as it is. So what would exactly happen is after, let's say, 10, 20, and 30. Okay. So like it wouldn't even execute because you know, when I would execute this, it would automatically show me an error that, the index doesn't exist. Okay. But if I were to do it in an, line by line way, so let's just say, till that program encounters the error, so it would be able to print 10, 20, and no, 10, 20, and 30. Yes. No, 10, 20, 30, and 40. Sorry. Uh, s- so it would print all this, okay, 10, 20, 30, 30, and 40, but then it would go into an error. So after 40, this, the index increments by 1. 4 is less than 5, so 4 is still less than 5 because 3 would be the last index of this array if it has 4 elements. I said no, the index of an array is number of elements in that array minus 1, the last index of that array. And So basically, after that, 4 is less than 5. Then, the loop, it will proceed to this line where it would now throw an error because the index is out of bounds, basically. If I have to do it, in an interpretive way, sorry. If it was done by Python or anything else. So, not anything else, Python. It's an interpreter, na? So that's why. Here the okay. So we have this okay. As a more okay. So yep. Sorry. For example, if you change the definition of an array to have 4 elements but forgot to update the condition to while index less than 4, the code would panic. As I said, it's also slow because the compiler adds runtime code to perform the conditional check of whether the index is within the bounds of the array on every iteration through the loop. Okay. Yep. So so it actually does that, during compile time. Like I'm not so sure, like I should say, because I don't have that much, depth of knowledge in that. But we'll just go ahead. As a mere concise alternative, you can use a for loop to and execute some code for each item in a collection. A for loop looks like the code in listing 3, 5. Okay. So this is like for element in A. So I should actually just use an example over here. Okay. If you could just wait a sec. So I think for is an loop is an expression, right? So that's why it doesn't need semicolon. There you go. just print the elements first. Okay. So I will be commenting. So there you go. So now there you go. Simple code for loop. Okay. When we run this code, we'll see the same output as in listing 3, 4. More importantly, we have now increased the safety of the code and eliminated the chance of bugs that might result from going beyond the end of the array or not going far enough and missing some items. Okay, yes. Because now we've, defined an element which will iterate through the entire array. So it won't go back or front. It would be just in this range of the array. Just, it would iterate over every element. So there won't be any, danger of index out of bounds in this case. Okay. Using the for loop, you wouldn't need to remember to change any other code if you change the number of values in the array, as you would with the method used in listing 3, 4. Yes, which was the while loop. Um, the safety and conciseness for loops makes them the most commonly used loop construct in Rust. Even in situations in which you want to run some code a certain number of times, as in the countdown example that used a while loop in listing 3.3, most crustaceans would use a for loop. Okay. So, yep. Okay, I understood. The way to do that would be to use a range provided by the standard library, which generates all the numbers in the sequence starting from one number and ending before another number. Okay, so here's what a countdown would look like using a for loop and another method we've not yet talked about, rev, to reverse the range. So, okay, so this is how it is done. I'll try this sometimes later. Or I think, like I did cover for loop. This basically, the range 1 to 4, I think, and this is the reverse of range. Summary, you made it. This was a sizable chapter. You learnt about variable, scalar, and compound types. I was just checking the volumes. I think I spoke too closely to the mic. You made it. This was a sizable chapter. You learned about variables, scalar, and compound data types, functions, comments, if expressions, and loops. Okay. To practice with the concepts discussed in this chapter, try building programs to do the following: convert temperature between Fahrenheit and Celsius, generate the nth Fibonacci number, print the lyrics to the Christmas carol 12 Days of Christmas, taking advantage of the repetition in the song. Okay, so we will do, I think, between Fahrenheit and Celsius. We could actually do Fibonacci also. But we'll actually try anything. So now I would actually show you how to convert an algorithm to code basically. So the thing is, when you're coding, you only need the logic. If you know the logic, then you can code it in any language, provided you know the constraint and the syntax of the other the language in which you are going to code in. So you you know this is basically how people do it. You have a algorithm and then you convert it into code. So this in itself would be actually one of the best skills you have in your arsenal. So we'll just do a simple one. We'll convert Fahrenheit to Celsius. Okay. And we'll go for the formula. Okay. So Fahrenheit equal to 9 by 5. Wait. No, not in C. Just we will need only the formula. Okay. So let's say I have a temperature in Fahrenheit. So what I'm going to do here is main dot. I think main 2 has this whole thing. Oh yeah, I did this else if and all. Uh, so okay, if you could just give me a second here. Let me just shift this below because I need my main function to be clean for the for the time being. And there you go. Yep. So my main function is now clean. So this is now all commented code. Um, what we are going to do here is we might need to actually not loop. We need this. Okay. Oh, sorry. This only this. Or wait. Actually, we'll need this whole code. Sorry. I'm very sorry about this. No, I'll just copy paste actually. That would be better. Instead of just, picking up the entire code. Okay. Well, foil can, go out. Well, this code is already in, the study, like, programming tutorial, so there's no need for that code. And what I'm going to do here is there you go. Actually, we don't need. Actually, we do need this. Okay. So what we are going to do now, okay, is let temp this for Fahrenheit to Celsius, right? Temp Celsius. Temp Celsius will be our mm, temperature in Celsius, which will be F64. We need floating points for this, okay? So what we are going to do is replace number. So yeah, then height. Okay, it's not N, it's H Fahrenheit. Okay, so Oh no, wait. There you go. Yeah, I know. So the reason why this error is showing up because I changed the type. So here I would have to change this. Okay, we'll do this as F64. There you go. And instead of this, you know, also we don't need a loop. No, we'll do the loop. Now what we're going to do is break. Yeah, but found. Okay, now give me a second. We have to convert, right? 10 Fahrenheit minus. Sorry. Oh, it came. Yep. And I could actually. Celsius. Oh, sorry, S. Give me a second here. There you go. Now, what would actually happen is so in this loop, I wrote enter the temperature in Fahrenheit. So it would take the user input in floating point. Okay. So this is, and then it would parse it as a floating point, number F64. And since this is a loop, so the reason I've kept it as a loop, I was going to remove it, is because in case it doesn't parse properly, okay, then you would still get a chance to write the temperature. So unless and until you write the correct temperature, like in the correct format, you won't be able to get out of the program. And After that, the moment I get the Fahrenheit temperature, then I will break out of the loop with this, So this, it would calculate, the temperature in Celsius from this Fahrenheit value. And when the loop will break, the this value would be assigned to temp Celsius, our variable over here, and then the temperature would print. This is very simple. So let's just say our temperature 32 Fahrenheit is 0 degrees Celsius, right? So just write 32. Temperature is in Celsius is 0. Okay. And if I just write anything, oh, sorry. Here, temperature in Fahrenheit. So if I write letters or just if I just put in enter, then it won't work. And let's say 98.6 Fahrenheit, which is body temperature, 37 degrees Celsius. So this is working. This is how So this is actually a simple way of writing a program which converts your Fahrenheit to Celsius. Like this is actually very optimized according to me. Okay. And just put in this. I think spacing is required between. There you go. Now it looks like a Rust program. So this Celsius. So this is how to convert Celsius to Fahrenheit. Now, if you could just give me a second here. Sorry, I didn't mean to do this. So we'll actually do Fibonacci if I want to. The nth Fibonacci number. Like I know what this is. So it starts from 0, 1, 1 plus 1, 2. So the formula is the nth Fibonacci number is equal to n minus 1th Fibonacci number plus the n minus 2th Fibonacci number. It's that formula. So how, like I have done this before, but so this is Celsius to Fahrenheit, Fahrenheit to Celsius that we did. And I could also convert it into Celsius, into Fahrenheit also, which will, we could do. Where like, I did actually the Fahrenheit to Celsius. You can, like, if you want to, you can do the other one by yourself. It won't be that much of an issue. Because basically you just need to change the formula and the variable names. So the Fahrenheit gets replaced by Celsius gets replaced by Fahrenheit, and the formula gets replaced. That's it. That's the only thing you need to know. And I think like if you are learning, you can do this by yourself. I won't be doing it since I already know how to do it, and I did it just live. So with the nth Fibonacci number, so what we are going to do is I think the first Fibonacci number is 0 and the second is 1. So I think it's 0, 1, 1, 2, 3, 5, 8, something like that. It's 8, then 13. Uh, Fibonacci series. Yep, 0, 1, 0, 1, 1, 2, 3, 5, 8, 13, 21, 34. So this is how it goes. So see, the formula here is, I'll show you the formula. There you go. So assuming that f0 is 0 and f1 is 1, fn is equal to fn minus 1 plus fn minus 2. So this is the formula. It is a recurrence relation. Okay. So, since no, we haven't done arrays. We did do arrays. I think we would add elements in arrays or what? So nth Fibonacci number. Uh, so sorry, what I'm going to do here. Actually, the thing is, it would take some time for me to. No, actually, it can't be done, especially in Rust. The recurrence relations can be actually done here. And I won't need to use a function. Actually, I can do it in the variable itself, because it does support looping and like this. So what I'm going to do here, this would also be the same thing. Like, if you want to write this down, then I'll just put this in the comments. The shift. So first things first, I will comment this out. Then all of this is going down. Okay. And yep. So our programs are now separated. I'll separate this further. The more separation, the better, actually. Because I could actually see that these are different, types of code. And so I'll recopy this. Okay, Fibonacci is equal to. Now what I'm going to do is, sorry. And this time we actually don't need F64. This would be U32. U32. a second. I won't need to. Okay, I will need to loop. So let lut. No, sorry. Let fib 0 equal to 0. Okay. Let fib 1 equal to 1. Okay. No, the. Okay. Okay. So uh, okay, how do I solve this actually? I could do it with a function also, but I could do it like this also. I think I can. Uh, Wait, actually, I have a, you know, no, what, or I'll just try. Oh no, not again. Uh, Someone else is watching. Okay. So, element in temperature. So the problem here is I want to try to do it in this because there is a simpler way. I could just use a function. But since I've learned all this, so I would like to use something else. For element in uh, so if so we could actually do this. There you go. So, yep. Now I am actually break one. Give me a second here. There you go. Someone else is watching. Fib input is equal to break 0, else if fib input equal to 1, break 1. Else, actually, so no, actually, this if condition won't come. I need okay. Give me a second. Fib n is equal to your 0. So this will be n minus 1 and n minus 2. Fib n 2 is equal to 1. Okay. 0, 1, 2. Sorry, this. So n minus 1 would be this, and n minus 2 would be this. Okay. If okay, so no, wait. Okay, so if element is equal to 2, किसका बजा के अरे कौन है भाई गिव मी अ सेकंड हियर Okay, sorry, I was. Someone was knocking on my, door. Not fib number actually. Sorry. MUT. Put the mutable keyword. Okay. No, actually, wait. Not even this. Uh, so, fib no is not. There you go. And if number I'm sorry if this is no not fib input, not number, yeah, input. So I'm not sure whether this will work or not. Okay, because well. Okay. There you go. So this is my code, and why is it this variable? Oh, that's why. There you go then. There you go. Okay, so I think this should work, but this is still showing an error somewhere. So I'm not sure where the error is. Acha, this. No, this is not required. Sorry. So I'm not sure whether this will work or not, but I will try actually. There you go. So let me just test this. If this works, then I'll explain what I did here. Okay? Because if it doesn't work, then it's still the enter n, not nth. Okay, so enter n and then the nth Fibonacci number. So I'm not sure whether this will work or not. No, it didn't. It didn't work. So Fibonacci, because it didn't enter the loop. Let's say this. So if is this going to work? This is working. Now my problem here is say if I write 3 2, okay. Okay, less than Fibonacci input, I understood. 3 is obviously 2, and let's say we want 6 is 8, okay. We'll we'll go ahead and 8 9, we'll go for 9, I think. 9 is 34. So this is so basically now I will explain how I did my code. um, this Gemini keeps popping up. I don't know what the problem is. So now the explanation for this is so if I write let's say if I write 0, okay, here, let's say I wrote 0, the nth Fibonacci number is 0, okay. If I write 1, the Fibonacci number is 1, okay. So these are the base cases, okay. And other than that, now what will happen is I declared two, Fibonacci. So I declared two mutable integers, 0 and 1, and then I have a Fibonacci number, which will be the final Fibonacci number. Okay. Now for element in the range of 1 to fib input. Okay, so it is like I think exclusive of the fib input. So this will run till n. Okay, or if I write 3. So what this will do is so the value of this fib number will be the sum of these two. Okay, the n minus 1 and n minus 2. Now what would happen is since the loop would go ahead, so before going ahead, I replaced the n minus two, which is this. So n2 is this part, n minus two, and n1 is this one, with fib n1. So n2, the value of n2 would now be the value, n minus 2 will now be the value of n minus 1, and the value of n minus 1 would not be the value of this fn, since the loop is going ahead. Okay. So this loop will repeat till it reaches this fib input, and when it reaches this value, the element reaches this value, then it would exit from the loop, and then it would return the number that came. So then you would print the value that came, the nth Fibonacci number, which is this. So this is how I did my Fibonacci number thing. 4. 4 is 3. See, F4. So while I'm testing, the number I enter here will actually, will be cross-checked from here. So, for example, if I want to do, till 19, okay. So we'll just do 4181. So it works, okay. So this is how I do. If this is how you do a Fibonacci number. Okay. I think the volume must be too high. My voice must be ripping into the mic all the time. Uh, I need to test. Okay. Okay. So now that we are done with, and I think we don't need to do this. I won't be doing the third one. Okay, it's not. It is a little bit, but I tested it, and give give me 2 seconds. Sorry. Uh, Now, I was thinking I should actually go ahead with the ownership. You know, common. No, wait. This ownership is Rust's most unique feature and has deep implications for the rest of the language. It enables Rust to make memory safe guarantees without needing a garbage collector. So it's important to understand how ownership works. In this chapter, we'll talk about ownership as well as several related features, borrowing, slices, and how Rust lays data out in memory. But this is actually too long even for me. Uh, so I don't know how much time it has been. So let me just see the time. Top message is 1. Okay, so okay, what is ownership? Ownership is a set of rules that govern how a Rust program manages memory. All programs have to manage the way they use a computer's memory while running. Okay, some languages have garbage collection that regularly looks for no longer used memory as the program runs. Okay, in other languages, the programmer must explicitly allocate and free the memory. Rust uses a third approach. Memory is managed through a system of ownership with a set of rules that the compiler checks. If any of the rules are violated, the program won't compile. None of the features of ownership will slow down your program while it's running. Because ownership is a new concept for many programmers, it does take some time to get used to. The good news is that the more experience you become with Rust and the rules of the ownership system, the easier you will find it to naturally develop code that is safe and efficient. Keep at it. Okay, so this is basically how Rust actually manages the memory of the program, and maybe it is also a guide to how to efficiently manage memory. Memory management techniques, I think, or but I think it's actually covering the basics of memory management in Rust. So actually, this would actually be a big part. So it is safe to say that I will actually end this stream at this moment of time. So, well, actually, we did complete loops, and I actually, you know, so the streaming for next week will be a bit complex for me. And you know so since right now I'm actually streaming twice a day, but actually from next week onwards it will be back to my regular schedule of streaming once a day. And so actually I would be on a two day break, Saturday Sunday. And Monday, I'm actually not sure as to whether I would be able to stream or not. But I think I should be able to stream if I have the time. And I think Monday in the night only. And I think we'll continue with, I have my other stream going on. Uh, See, the next Rust stream will be on Tuesday, if I'm not wrong. And well, on Monday it would be a gaming stream. So we'll continue with that Armstrong boss fight, I think, in Metal Gear Rising. So, well, thank you for watching. I talked a lot, and I hope you enjoyed the video. I had fun. Sorry, not the video, the stream. Sorry. So I hope you enjoyed the stream. I did have fun, and I'm actually, trying to improve my speech here a little bit. So, actually, I, you know, thank you for watching. So, just tune in on Monday. To in I basically, since the time up here is an IST. Okay, so mainly I would be streaming in Indian Standard Time only. So my stream would be at in the night only. Now I'm not sure what time it would be, but just expect it after 8 in the night. So thank you for watching my stream. I hope you guys have a good day or